Now we know a number of you are using force envelopes already, and we hope to answer some of the frequently asked questions about this tool. So when working with force envelopes, essentially they give us an integration point along the member, several different integration points rather, and we're able to look at the maximum force of deflection and the load case that's responsible for that, as well as the minimum force or deflection and the load case responsible for that as well. And the force envelopes, as you can see here, are accessed through the actual view grids and properties toolbar. And the force envelopes can be used to view graphically, can be viewed graphically rather, for the entire structure, or just a single member at a time. And all this same information can also be viewed in a numerical form through a spreadsheet, in a numerical results spreadsheet. So we'll look at an example now with the following model. We've had distributed loads applied to this, and we want to be able to have some obvious looking envelope forces that we can generate from this. And you can see again, it's just a simple frame. I'll just show you what we have with this model. We have fully fixed supports. We don't have any releases, so it's just a moment frame. And we have our sections defined 305 by 305 by 16 millimeters. Now I want to show you the loads that are on this structure to get a better understanding of what we're working with. We have a self-weight load case, which is considering the effects of gravity. We have a live load case that we can see here, has 100 kilonewtons per meter, and a snow load case that is partially varying distributed load that tops out just at the top of this one column on the right-hand side. So let's go ahead and run a p-delta static analysis. The reason I want to run a p-delta static analysis is that I can account for any second-order effects that might occur due to any eccentricity or anything like that in my model that could cause those p-delta effects. So I'll click OK. We're getting a clean solution here. And now we can look at some of the different results. So I can look at, for instance, the snow load results. And here I can see, we can view our axial forces. Not surprisingly, we're getting a higher axial force of compression on this one side because the snow load is partially varying but more focused on this one side of the model. You can also view the shear force, in this case the Z shear force, and we can see how that's varying, as well as the moment diagrams. Now I can also right-click on these beams and get a better understanding of the behavior of each one of these members individually by clicking on this diagram. Here we can control the number of stations that we're choosing to integrate the results upon. So if I want, I can increase this to say a value of 100. We're getting a smoother representation of this curve. You can see here that this S-frame dialog is reporting the maximum force and the minimum force for this particular diagram, which is Y moment for the snow load. And we have the option here to click envelopes, and we can view the envelopes for this particular diagram. Now right now, I'm just still looking at one particular load case, so it's not really much of an envelope without multiple load cases. So I'll tell S-frame to create the envelope based on all the load cases. I'll just toggle this on here. And now we can see what we're dealing with. We're getting a different looking shape for one. We can see on this scrolling numerical results spreadsheet here that we're getting the result highlighted for the maximum MY at each location where we scroll our mouse, and the load case that's creating that maximum MY. And if we scroll down here, we also get the minimum MY and the load case that creates that load as well. And we can do the same thing. We can look at Z shear, for instance, and we can get the same results for each one. And this is just highlighting the particular diagrams values that we're interested in. Now we can view this either for a single member, like I mentioned, or the entire structure all at once. Now many of you, when you're working with load case envelopes, you may start off by just clicking this envelopes button, view envelopes, and you'll get this message saying invalid range. Basically what SRAM is trying to tell you is that you're only looking at the results right now for a single load case, or maybe just a single load combination, and it's not really worth making an envelope of that because, again, it's only one load case participating. So it's just letting you know. What you can do, though, is you can specify either a range of load cases and then enter the range here, say 1 to 3, or you can just say I want to view an envelope for all of my load cases. And now I'm viewing this information for all of my load cases, and I can see my bending moment envelope, my shear force envelope, and everything like that. And again, we can change the number of stations we have to integrate this as well. Now this information, again, is available both graphically and numerically. So if we wanted to, we could certainly look at the same information numerically. We just have to, again, define which load cases we're interested in looking at. So I just click all load cases here, and it's showing us those results. So here it's showing us the minimum and maximum results at each location and the load case in that envelope that's creating those results.